Welcome to this second video. I like this second video. Second third should be a little simpler. Last video today is going to be something. We'll see. Anyway, so remember demand functions. We're going to talk about demand functions here. And remember that demand functions correlate how much you want to sell, with how much you can charge for each thing. Okay, so if I want to sell 500 things, I'm going to have to charge less than if I only wanted to sell 100 things, right? The more things I want to sell, the lower the price I'm going to have to sell them at, right? Or conversely, right? If I lower the price, I can sell more things. All right, and that's essentially what demand functions are, a relationship between how many things we want to sell and what price we're going to charge for them. So let's keep this in mind as we go into example 3. Example 3 is if P equals 6 minus 1/2 X, $1,000. Goodness. Find the production level that maximizes revenue. And this is interesting for a couple of reasons. First thing, I haven't given you a revenue function. Second thing, let's talk about this demand equation, right? This demand equation says, let's say I wanted to sell like 2 units, right? If X were 2, we get 6 minus 1. P would be 5. If X were 2, P would be 5. So if we wanted to sell 2 units, we'd have to charge $5,000 for each of them. We're probably not talking about like yo-yos or something here. All right. Or conversely, look at the y-intercept, right? If X is 0, that means that if I charge $6,000 for this item, nobody's going to buy it. X will be 0. So you can think of X as either how much we're producing or how much we want to sell. In most of these situations for our class, they'll be the same number. All right. And we can go on and on with like looking at different prices and productions. We want to maximize revenue. What is our revenue function? R of X equals something. All right, so we don't know. But we sort of do know, right? If I'm selling 15, all right, what are these things that we're selling for $5,000? If I'm selling a used car or whatever, if I sell 3 used cars for $3,000 each, the revenue is $9,000. If I sell 5 used cars at $1,000 each, the revenue is $5,000. What are we doing? We're multiplying how many things we sell with how much we sell them for. We've got some variables for that, right? Revenue is just going to be, items sold times the price that we're selling them for. So how many items are we selling? X items. X is just how many we're producing and selling. What's the price? Price is that variable P. So now, if price is equal to 6 minus 1/2 X, let's replace that. Right? If things are equal, we just replace them, 6 minus 1/2 X. And by George, by golly, gee whiz, we've got ourselves a revenue function. We want to maximize the revenue. Can't maximize the revenue until we know our revenue. All right. So now we have a function. We'll find its derivative, set it equal to 0, find that maximum. Okay. And again, usually it's a good idea to simplify this a little bit before moving on. So we're going to say that our revenue function is equal to 6x minus 1/2 x squared. That's our start. We want to minimize this. Maximize this. Goodness, this is why I teach college. I don't own a business. We got to minimize our profits, guys. Woo. All right, so let's take the derivative. Again, pretty simple power rule here. We're going to get 6 minus x is our derivative. Let's connect topics. This is the marginal revenue. Right? This is the marginal revenue. Oh, I just clicked with the last video. We got that the minimum marginal cost was 0. Actually, no, it doesn't connect that way. Never mind. We could use a local extrema test, but we'd find out that it was not a maximum or a minimum. Anyway, marginal revenue right here. We want to find out when the marginal revenue is equal to 0. Marginal revenue. This is the additional revenue at a current production level of making another unit. So off to the side, right? So don't write this down. I'm going to erase it maybe later. Off to the side, we don't need this. But right, if R prime of 0 is going to be 6. So if we're not making anything, making our first unit, selling our first used car, we'll get a $6,000. The additional revenue from going from 1 car to 2 car is going to be 5,000. All right, and so on. This is just the additional revenue generated by increasing production or increasing selling by 1. And again, remember X is in thousands of dollars. Okay, so we just want to find, right, max critical points in general are when the derivative equals 0. Oh, that's too many derivatives. Slow down, Jason. So that's what we're going to do next. I'm not on the erasing key. Oh my word. This is really a disaster striking today. All right, so we just set this equal to 0, solve for x. Add x to both sides, we'll get x is equal to 6. All right, and we could use a derivative test to show that this is a maximum, but I'm not going to make you do it for this section. All right, so question asked, find the production level that maximizes revenue. 6 units. That's the production level that maximizes revenue. If we make more than 6 units, our revenue is going to go down. Because if we want to sell more than 6 units, the price that we have to sell them at is just too low. If we have fewer than 6 units, the price is higher for each one, but we're just not selling enough. So this is that kind of balance for the price and demand and production. All right, good luck.